Alright, so now we're going to start talking about some easier way to draw these organic compounds. I'm not going to talk about throwing in other elements till we simplify the process of representing them on paper. At least, if not for you, for me. Alright? So, I've only got so much ink in this pen. I don't want to waste it all drawing Lewis structures. So, we're going to talk about line drawings first. They're also known sometimes as zigzag or skeletal structures. So be aware there's multiple names that can show up, but they all mean the same thing. There's probably a few others I'm forgetting as well, but you'll know them because they're just lines. All right. So before we were drawing things like what did I draw? I think I had 6 carbons in a chain. No, I just had 5. Right? Yeah, I had 5. Okay. And so I draw a Lewis structure of that. You should be all impressed at how fast I am, and also how scattered I am while writing this one. I'm all over the place. Not very systematic at all. But we have a chain with 5 carbons. All hydrogens around it. This is our Lewis structure, right? We've talked about these before. Now we've pulled them into the realm of organic compounds. But that took me a little bit of time to write. I had to do a lot of dashes, and if there's anything that has lone pairs, I got to start dotting in the lone pairs, right? I got to account for all of my valence electrons and all of my atoms present in the molecule. I have to draw everything. I have to show you everything in the molecule. There are no secrets there. So, if I'm going to simplify it, guess what I have to do? I have to start showing you less. I have to start implying more. I don't show everything. So this molecule's line drawing looks like this. 1, 2, 3, 4, 5. Oh, it looks like an M. Okay. That's it. That's the line drawing. That's the whole thing. People often are shocked. Like, it can't be that easy. Well, it is. It is that easy to draw. The trick is recognizing that this means this. Okay? So we're going to break this down. So I just showed you what it was, but I explained nothing. So we're going to explain what I just did. So line structures are only going to show a couple things. We don't draw the hydrogens. Do you see any hydrogens in here? I sure hope not. If you do, clean your screen. I think you got some bugs on it or something. So we don't draw our hydrogens. We also don't explicitly write our carbons. So I'm going to break this down in a minute, but we show carbon-carbon bonds, but not the carbons themselves. And we'll talk about how we handle these with other elements later, but for now we're just dealing with carbon and hydrogen. So essentially we just draw lines. We don't have to write any letters right now. We don't have to do anything. That'll get a little bit more complicated when we bring other elements in, but the overall process stays the same. So this is just the bonds between carbons. So this line right here represents this bond right here. And then this line right here represents this bond right here. This line right here represents this bond right here. This line right here represents this bond right here. And so what am I hiding? Well, there's a carbon here, 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 and here. So I didn't explicitly write them, but the end point of every line, if it's not labeled in any way, that's a carbon. If it's labeled with some other element, guess what that means? That means some other element's there. But we'll talk about that more later. But if you don't see anything there, but it changes direction, that means there's a carbon. If it's a terminating line, it's a carbon at the end of the chain. Okay, so there's a carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5. All right. Now the other thing is, I didn't draw any hydrogens. How do I know how many hydrogens there are? And this is where you have to do a little work. Okay? So remember, these carbons are all here. And I think it's easy to recognize that we're just not writing C's for carbons, right? We're showing these bonds. But then the hydrogens get tricky. So, how do you know how many hydrogens there are? Well, remember, every carbon is making 4 bonds. So we just straight up hide the hydrogens. We hide the hydrogens, we hide the bonds of the hydrogens. So if I only see 2 bonds on a carbon, where are the other 2 bonds going? It has to make 4 bonds. They're going to hydrogens. If it's only making 1 bond, this carbon over here only has 1 bond. What is it doing? It's going to 3 hydrogens. So we show that on our Lewis structure. We hide that on our line structure, and that lets me just. I can just zigzag all over the screen, drawing molecules in the blink of an eye. And the great thing is when I'm doing examples, I just start zigzagging. Maybe I slash some stuff in here and there, and I've got a molecule, and then I figure out what it is later. I'll make you guys figure it out. But if I'm looking at this and I go, well, how many hydrogens are in this structure? Well, I can break it down. I can just be like, well, this guy needs 3 hydrogens. This guy needs 2. This one needs 2. 2 over here. 3 over here. And so I get 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Guess what I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I can count for all my hydrogens, but they're not originally in the line structure. I have to tease that out of it. I have to do work. So we are hiding the number of hydrogens. You have to do detective work. You have to sleuth that out. All right. So let's do another example here. Let me draw. Let me blind you with the bright light. The furious bright light of line drawings. Let's do this. Let's look at this, right? So, a couple of questions here. How many carbons? And how many hydrogens? These are the meanest questions I can ask out of line drawing, especially this one. So take a minute, see if you can figure it out. Give it a pause, take a crack at it, and then I'll work it up. Alright, so how many carbons? I just count. You might have even heard me counting out loud a little bit when I drew this. I had to stop because I caught myself because I realized I didn't have to know. So I've got 1. Don't ever forget there's 1 on the end. 2, 3, 4, 5, 6, 7, 8. How many carbons? 8. So this will be known as octane, if you're curious. If you don't know what octane is, now you know. Alright, it's a series of mountain ranges with a ramp. I like to interpret my line drawings. Alright, so how many hydrogens? Now you can't just look at this and be like, oh, it's 25 or something. You've got to fight the battle 1 carbon at a time, and then just total it up, alright? If you do anything else, it's just too easy to trip yourself up. So, we're just going to start on the left, we're going to work our way right, and we're just going to carbon by carbon. How many hydrogens on this one? How many hydrogens on this one? So on and so forth. Once we get them all done, we come back, we just add them up, we get our number. So, remember, carbon's making 4 bonds. It's always making 4 bonds. I didn't show this carbon making 4 bonds, but it is making 4 bonds. I just didn't draw them all because that takes too much time. So, I have 1 bond being shown. There's 3 bonds missing. That means there are 3 H's here that I did not draw for this structure. Okay? Because again, we're going to have 1 bond here, and then there's going to be 2, 3, 4 more, or sorry, 4 total, and 3 of them are going to go to hydrogens. This carbon is making 1, 2 bonds, so there are 2 missing, right? 2 plus 2 is 4, right? So there's 2 hydrogens missing here, and that's going to carry through, right? This is 2 bonds, so there's 2 missing, 2 hydrogens, 2 hydrogens. You can start to notice a little bit of a pattern with these. And then on the end, it's only showing 1, so 3 H's. Then we just total it up. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. With 18 hydrogens. Okay. So, let's do one more example. And we're going to mix things up a little bit. Alright. What if we have something like double bond in there. And yeah, we'll leave it at that. So if you wonder what a double bond looks like, there you go. And we'll do one more as well. We'll do triple bond. All right, so I'll talk about the triple bond one because that's a little bit tricky. This is carbon, 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 carbon. So it's 4. We draw triple bonds flat. If you put something like this in the homework that you're working on or whatever, you're doing it by hand, I'll give it to you. If you were to bend it, I'm not gonna bust you on that. But be aware if you see it printed copy, that's the end of a line. That's the end of the triple bond. That's the other side of the triple bond. That's the end of a single bond coming off the triple bond. So to be clear, the Lewis structure for this molecule with the triple bond, I'm just going to draw the whole thing. Looks like this. Okay? So it's 4 carbon chain. 1, 2, 3, 4. And we've got a CH3 over here. We've got 3 hydrogens because this carbon's only making 1 bond. This carbon's making 3, 4. So there are no hydrogens on it. Same here. 3, 4. No hydrogens on it. And then on the end, this carbon's making 1 bond back. And that is 1, 2, 3 bonds missing, 3 hydrogens. Okay? So that one's tricky. Double bond's a little more straightforward. You just slash in an extra line for the most part. There's a little extra trick to it we'll talk about in the next video. So where are the carbons on this? Same place they were before. There's a carbon, there's a carbon, there's a carbon, there's a carbon. I got 4 carbons. This carbon has 1 bond being shown. So it has 3 H's. This one has 1, 2, 3 bonds being shown, right? Because the double counts as 2 bonds. So it has 1 hydrogen. This guy right here has 2, 3 bonds being shown. That means there's 1 hydrogen remaining. And then we've got 3 over here because it has 1 bond being shown. So the number of bonds being shown plus the number of hydrogens should equal 4 for every single carbon, right? We got 1 plus 3 equals 4. We got 1 plus 2, 3 equals 4. 3 plus 1 equals 4, so on and so forth. All right, so we just total it up. Figure out how many carbons, how many hydrogens are in there. So this is what double bonds look like. Nothing too creative, right? Just double line. Triple bonds, this is what they look like in line drawings. And again, it's nothing too crazy. It's 3 lines. So the last thing I'm going to do in this video is talk about why we draw them this way. Why are we doing this sawtooth pattern? You know, why can we slash in a double bond, but we can't just slash in a triple bond? Even though I'll let you do it, why can't we do it according to the letter of the law? And the reason has to do with the shapes of the molecules. So when you have carbon making 4 bonds in 3 dimensions, what you get is the following. You get a bond angle of 109.5 degrees. So when you draw a single bond, I'm going to get out a protractor and I'm going to make sure that this is exactly 109.5 degrees. If I see 109.6, we do offer biobonds again in the fall, and better luck next time. No, I mean, you know, you can mess with the angle, I don't care. But I want you to know that's exactly 109.5. And if any of you put your protractor up at the screen and see anything different, it's because your screen is miscalibrated and you need to adjust it. So adjust it until this is 109.5, and then all your aspect ratios will be spot on perfect. Don't worry about the black bars along the sides or the top after that. It was just the factory screwed up, and sometimes you got to fix that. Oh, and if you're wondering what I did over here, so this bond is flat on the paper, this bond is flat on the paper, so it's like this. Alright, there's a bond, there's a bond. 109.5 degrees. It looks a lot like 90 degrees, I know, but again, you need to calibrate your screen. This is sticking out of the paper, and this is going into the paper. And so what you have is you have flat bond like this, you got one that sticks out. They're all 109.5 degrees apart. It's hard to get this on camera. So there's one coming out, and there's one going back. So they all spread out in 3D space away from each other as much as possible. Now when we have a double bond, it is able to be represented flat on paper, and what we get is 120 degrees. And so that's, you know, not bad. It works. It's close, right? Now the issue is when we have a triple and a single, it's 180 degrees. You got a triple bond, you got a single bond pointing straight away from it. Okay? They're not going to rotate like 90 degrees. They're going to be 180. They're going to get as far apart as they can, and that's how they do it. And so that's why we draw our triple bond, and then there's a single bond that comes straight out of it. Because this is 180 degrees. And this is, you know, it's like 120. Close enough. You don't have to, you get your protractor out and you can take your 109.5 and you make it 120. You know, better do it. Better safe than sorry. And if you try to tell me, oh, I did my homework right, and your screen is miscalibrated, Joe, I'll tell you no, I calibrated my perfect 109.5 here. So it's on you now. I warned you, calibrate your screen. Alright. And again, if you were to do something like that, it's okay for this class. I want to be clear about that. I want to explain, I don't often model appropriate behavior in my life, and so I like to with the line drawings. It washes away a lot of the other stuff that I try to get away with later. So, you can get away with that. You're going to see me do this. So just be aware. And you're going to see the book do this. And you're probably going to see, you know, any online questions you have to answer to that. So just be aware, be familiar, and know how to recognize it. Okay, so that's kind of all details. Let's do a little more practice. This is something that practice really helps with, so we'll practice it a little bit. So I'm going to start out, I'm going to draw a series of Lewis structures. We'll do, how about 3 of them? And I'm going to want you to draw the line drawings for them. So if we have, I'm not going to do too many carbons now. Ooh, I'm gonna put a branch in it because I forgot to talk about branches. Okay. So yeah, that works. So we'll have a 4 carbon chain with a 1 carbon branch. So here's our full Lewis structure for the first example. So I just filled in my hydrogens. Did you need those to draw a line drawing? Not necessarily. Alright. So right off the bat, I hit you with a detail I haven't talked about. Think about how you might handle that. The answer is we're just going to repackage something we've been doing the whole time. So just think about it. How do you represent a carbon-carbon bond in your line drawing? Alright, and then we'll go triple, single, double. Yeah, that works. I don't want to draw more than 4 carbons. Got a hydrogen on that guy. We've got a hydrogen on this guy. We got a 2 on this guy. Alright, so there's our second example to practice with. And let's do one more. Okay. Do a 5 carbon chain. Carbon, 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 carbon. Alright. This is going to get a little messy here, so just hang in there. Hydrogen, hydrogen. Whoa. Trying to write that too small. Hydrogen. I thought you were a fine tip marker. Nothing fine about this tip. Okay. And we're just going to fill in all these hydrogens. Hopefully my hand isn't blocking too much. But again, all you need is that carbon skeleton structure. And then once I start saying I'm filling in the hydrogens, that actually means you have all the information you need. Okay, I'm going to draw a little line here to help separate these, because I didn't use my paper appropriately for space. Okay, so it's a disaster, whatever. welcome to my class. All right. So, take a second, copy these down, practice them. You're going to draw the line structure over here. And I'm going to do that too in a second. Let's see if you can handle it. I've thrown some curveballs at you. Okay. So, let's do the first one. Carbon, carbon. Boom. It's a double bond. Okay. Got a double bond there. My main chain is going to go boom, boom, boom. That's going to be my main chain. So 1, 2, 3, 4. 1, 2, 3, 4. And on the third carbon, I have a side chain. What did I just do there? I just drew a side chain. Maybe you figured this out. And sometimes people draw them going in, but generally you want to just kind of open them up to the most space possible because sometimes there's other stuff on these. And so you usually, you just want to take them off the peak of the mountain. Bottom of the valley, peak of the mountain. Just launch it. Make it into a volcano, or there's, a road running between the two elevations here. So double bond, double line. I've got 1, 2, 3, 4 carbons. 1, 2, 3, 4 carbons in my main chain. And I've got a side chain of 1 carbon on the third entry. So 1, 2, 3, and then single carbon coming on. So single line. That's what we got there. So that's how we handle side chains. Might be very helpful for that third practice problem now that you know that. So maybe revisit this one real quick. See if you are able to make sense of it now if you weren't before. Alright, so next we've got 4 carbons in a chain. I've got triple bond, and then a single, and then a double. That works. Maybe I can make it look a little cleaner, right? And I can do this too. It doesn't matter whether that double bond goes up or down. But that's it. That would be good. I've got carbon, triple bond to carbon, carbon, single bond to carbon, straight off of the triple bond. Correct behavior. Again, if you were to do that, whatever. And then I've got a double bond angled off of that single bond. So double bonds don't go straight. They're not 180 degrees. Remember, talked about the bond angle. And so that would be it. Both of these work. Doesn't really matter whether the double bond goes this way or that way. Just like, you could start all these by going down, up, down, up. I just like to go up, down. I like to draw mountains, not valleys or canyons. Personal preference, Had a long conversation with Bob Ross about it once. Talked me into drawing happy little mountains instead of depressed little canyons. Alright, so let's look at the last one. No double bonds, no triple bonds. Going old school on this. But lots of side chains. I drew so many side chains that I just destroyed my paper spacing. Okay? So first, when I see lots of side chains, you know what I do? I just identify the long chain and draw it. Here's what I'm going to draw first. So I've got 1, 2, 3, 4, 5 carbons. All single bonded. 1, 2, 3, 4, 5 carbons. All single bonded. I'm not done, but that's how I start. And I just start adding side chains to it. So carbon number 2 has a single carbon side chain. There we go. Carbon number 3 has a 2 carbon side chain. So I have to put a bend in there to know there's a second carbon. And then the next one has a single carbon side chain. Alright. And then we're done. And so you've got kind of a windy road going between 2 volcanoes. That's what you're looking at here. Again, interpreting. Whereas this is I don't know, kind of looks like a duck. Definitely, right? Totally. And then here, you got like a, I don't know what that is. 2 mountains, staggered, road going up between them and another one. A lot of mountains. Alright. So, that's how you draw these. I always recommend start with the main chain, add double bonds, triple bonds if you need to, add side chains to it. You start there. That's what I do. Again, you can be a little bit tricky. If you want to do the triple bonds correctly, then you gotta plan ahead a little bit. But if you're just gonna do zigzags and slash in all your double and triple bonds, it actually goes faster. Alright, so next we're gonna talk about another way to shortcut these structures. We're gonna talk about condensed formulas. Or condensed structural formulas, I guess is the full name. Some people call them condensed structures, some people call them condensed formulas. The full name is condensed structural formulas, but I live in a business where we're not going to say that, so we cut out different words. They all mean the same thing. But it's just another way of handling this without drawings. So this is like all drawing, no letters. That will be all letters, no drawing for the most part. Alright, and so those will be the two techniques we'll expect you to know in this class.